Welcome to Data Science 1, Probability, Expectation, and Continuous Distributions. Things we're going to need to remember: sample space, random variable, cumulative distribution function, and the probability density function. So if you remember, we did expectation under the discrete setting. So if you haven't watched that video yet, you should probably go watch it to get a hang of what we're doing here. So the idea is we're going to find the expectation of some function g of x, which is a function of our discrete random variable here. And we have a probability distribution that goes along with this. So we're interested in the expectation, and here's the formula we got before. And basically it just weighs the outcomes of g of x by how frequent x is given by f of x. Okay, so basically how often does x occur? If it occurs a lot, then give g more weight. If it doesn't occur a lot, give it less weight. Now, for a continuous random variable, the definition is virtually the same. The big difference is we're going to replace our sum across all x's by an integral that goes across negative infinity to infinity, which is all the x's on the real line. So you can think of this as a sum because it's a limiting sum, but we don't need to get too far into it if you haven't had calculus, but it's just a sum. So when you see this, don't think it's a whole lot different than this. Same idea. The weights are not probabilities now, but it's just how likely that value is. Okay, we had a mean before, right? It's the balance point of the distribution. And here we found it with g of x equals x, the identity function. And we would take the expectation over all the x's. This is the formula we had. Now we're going to do exactly the same thing we did before. We're just going to put an integral here and a dx on the end. And that'll give us what we need. So exactly the same. Okay, we put an integral here, dx on the end. It's really a sum. We're just looking at the average weight of each of the values of x, and we're weighting them sort of on how likely they are, not by their probability. Okay, we can move on to variance. Variance is the measure of spread, and here we have that the variance is a discrete random variable. Here's the formula we found. There's a mistake here. It should be sigma squared. Go back and fix it. Okay, so here, same idea. Replace the sum with an integral, put a dx on the end. Boom, done. Okay, real quick summary here, because this needs to be a short video anyway, because I'm just showing you that these ideas exist. We're going to actually apply them along the distributions along the way. So you'll see lots of examples of these as we go along the way, because as we move through the continuous distributions, we want to look at each of these properties. So what do we find out? Expectation works in random variables, continuous random variables as well. Ideas are exactly the same, balance point and measures of spread. Big difference is the replacement of the sum, that sigma, by the long s, which is an integral. And we'll be looking at these as we move on through the next distributions, and we're going to start them in the next video. See you there.